The next section is about justifications. It's about if you're asked to support your answer or justify your answer, and it's some definitions of critical points and inflection points. So these are the words to look out for. You want to look out for questions that say explain why or justify your answer. And there are some existence theorems that are out there that you should be aware of. The first one, so if you see a question like explain why there must be a value of c on this interval such that f prime is equal to this, or explain why there must be a value of r such that h of r is equal to this, or explain why there must be a value such that h prime is equal to this. You get the idea. The existence theorems, there are two big ones, the mean value theorem and the intermediate value theorem. The mean value theorem says that the derivative is going to be equal to the average rate of change at some point on the open interval. So these questions are about the mean value theorem. They're saying the derivative is going to be equal to the average rate of change for some point. So f prime is equal to the average rate of change, but this one says there is no point for that. Right? The other one, this one I didn't circle, is the intermediate value theorem. The intermediate value theorem says that the value of the function must be equal to a number. The intermediate value theorem says if your function is continuous, then it takes on all of the values between f of a and f of b. So for this function, my function has to take on all of these y coordinates because it takes on this one and this one, so it must take on all of the ones in between there on the interval for some value c. So there exists a c for which my function is equal to m. That's the intermediate value theorem. If you're going to use intermediate value theorem, make sure you can justify that your function is continuous. Just so you know, all of our basic functions are continuous. You know, natural log is continuous on its domain, square root of x is continuous on its domain, polynomials are continuous, etc. The mean value theorem says that if your function is continuous and differentiable, then there exists some value c for which the slope is equal to the average rate of change. So here's the average rate of, the slope of this line is the average rate of change, and the slope of all of these tangent lines is equal to that average rate of change at these values c. The mean value theorem only promises that there's at least one place where it happens, and it only promises it if your function is continuous and differentiable. You cannot use the mean value theorem if you don't have a differentiable function. There's also a mean value theorem for integrals. It just says that there is going to be some value, some time, when your function takes on its average value. But your function has to be continuous in order to use the mean value theorem for integrals, and it promises you that the value of the function is going to equal the average value of the function for some value. I think that usually you can get away with just the intermediate value theorem. You usually don't need this mean value theorem for integrals. I also wanted to point something out. All of the wording of these is going to be similar. There exists some c, there is a value, those kinds of questions. The definition of critical points. A point is a critical point if the derivative is equal to 0 or if the derivative does not exist. Be careful that you're not saying that a critical point, a place is a critical point, is a maximum or minimum there for sure. Maxes and minimums can only happen at critical points, but they could also happen at endpoints. But they don't have to happen at those points either. So you need to either see a sign change on the first derivative or a horizontal tangent line and concave up or concave down in order to say for sure whether you have a maximum or a minimum. Oh, I know what I was going to say. Don't confuse critical points and endpoints. An endpoint is only a critical point if the derivative is also 0 or does not exist. So be careful of the difference between critical points and endpoints. And then the last thing is sometimes you're asked to justify that something is an inflection point, and sometimes I see people kind of stumble. They want to say that it's an inflection point because the second derivative is equal to 0. But an inflection point can actually happen if the second derivative doesn't exist. But the important thing is the sign change. Your second derivative needs to have a sign change. Make sure you mention that sign change or a change in concavity. The inflection point is not just the second derivative equal to 0. There is also a change in concavity. All right. Thank you so much. Bye.